All right, here's the next part of exercise number 1. This is procedure number 3. Take one bar magnet and place it on the table. Then place a piece of plastic on top of it. That's like an overhead. Unfortunately, I do not have them. Again, I mean, it doesn't matter. I can use a piece of paper. So I'm going to put a piece of white paper on top of this. Then watch what happens. I'm going to use this. These are iron filings. They're just tiny little bits of iron that are flaked. So iron is a ferromagnetic. When I put it on top of the magnet like this, you can see that there's a pattern that develops. So it's kind of swirly a little bit. And actually notice how these things kind of stand up. I don't know if you will see it when I start to move it. You see how I move it to the side? It's a three-dimensional field. These magnetic fields come out as well as sideways. So it's a three-dimensional. Now these magnets aren't as strong as you'd expect them to be, but this is actually more like a quadrupole. But just describe what's going on. Let's move it this way. So you can see that these iron filings move outward in this direction, and they curve around like this. And you can't really describe them standing up, but you can see they're standing up like they're at attention. And the same thing happens over here. The field lines go out of the poles like this, and by convention they go out of a north pole and into the south pole. I can't remember which one it is. So just draw it, instead of drawing the individual dots, just kind of draw how the lines look like. You've got lines going like this, lines going out like that. Now there is some weird stuff going on here. What happened is that these things get dropped from time to time, and you can get, this is actually a weak quadrupole in here. There's an extra couple tiny little poles that have developed in here. I was kind of rushing to get all my equipment in my van, so I didn't remagnetize them. So this definitely is the North Pole and South Pole. It's just that there's also, it's developed another little quadrupole inside of here, which can happen if it's sitting for a long period of time. Okay, so you guys got that one? Because then what I'm going to do is I'm going to put another bar magnet next to it. And this time I just have to see which one is this. This is the South Pole. So what I want to do is put two South Poles next to each other, and then I'm going to put the North Pole next to the South Pole. And then we're going to try and see what happens. I'm going to jigger more. So this is two opposing poles, two like poles together. You can still see that they're kind of up, but notice there's nothing that goes from one pole to another. There's pretty much empty space in here. That's the main thing you want to see about two opposing poles. The force lines do not go from one pole to another. They repel from there. Now what if I move this to the side and change, put a North Pole next to a South Pole like this. Now what I'm going to do is put my, now I can't see where the poles are, but I just got to make sure they're, oops, they just stuck together there. All right, so now you can actually see, I probably put actually too many of them. This is the middle in between them. You can see that they're definitely going from one pole to another pole. Do you see that? So that indicates attraction, and you can kind of see when I fan it out that they curve off in this direction. So this is the North Pole, and this is the South Pole. And in the previous case where I had south and south, there was nothing in between there. But you can see that there's lots of iron filings. They're lined up right from north to south pole, and that's the direction of the field lines.